Hello, my name is Mr. Gelders. I am the science teacher at Hialeah Gardens High School. I'm here with my science class. We're going to be getting into the wetland. We're going to observe how a soil is hydric. This is a class about hydric soils. Basically, hydric soils are soils that are commonly associated with wetlands, like this one. A hydric soil is a soil that has been saturated with water for a long time, long enough to become anaerobic, meaning lacking oxygen. As we go in, we're going to be able to observe, as we dig the holes, the different layers and colors in each horizon as we dig in deeper. Also, we're going to see the different types of texture that each of these horizons or each hole has, because the texture and color has a different indicator for each type of hydric soils. All right, so let's go inside and see what we find.
Damn.
All right. Pause. Ponle pausa. Okay, vamos.
Yeah.
All right, it's me here again. We are going to walk over to first. We're going to be looking at a slope area over there. As you can see, the slope area. And we're gonna dig a hole in there, and we're gonna be able to see the different types of, as I said before, horizons, texture, and color in the soil. After that, we're gonna be walking up the other side, and we're gonna also dig a hole in a flat area, which is not gonna be a slope. All right, and we will also take a look at the texture and color of the soil. And after, we will see, we are looking up to find a depression and dig a hole in the depression and see also what is the type of soil and the type of color that we'll find in there. We will be comparing the soil as we get the earth out of it for texture. All right. What we find here is basically very black. This is not really greasy, but we have some grayish, as you can see, also in the soil. There's an earthworm in there nicely. All right, this is what we'll call probably a dark surface. I mean a depleted surface, because the color in the matrix is being depleted. You see some gray in here. So this is some signs of reduction in the soil. All right, so let's move on to the. Well, this is on a slope on the wetland. We're looking here that the first, I would say, first 2 centimeters is just regular mucky material, a little greasy. But as you go below, the texture is actually greasier. And not only that, we can see the different. It's kind of hard to tell. On the colors, the matrix is black, but if you can actually see with the camera here, we have this color that is, you see, kind of grayish. But if we look at this one, oh, let me get another one from here. They're different colors, right? You see it? Mm-hmm. So this. It's me to believe that this is probably a depleted dark surface. So the getting reduced. It's changing colors. It's hard to tell at the depth, so you have to put it in the sun. And here you can tell the 2 different types. Okay. Soil. More back. Okay. Right there. This is kind of mucky material. Fine. Okay, so the different types of soil in 2 different types of soil in the same hole. All right, so this is what we found on a slope. Now we're gonna go to what we call a flat surface. We're gonna see probably more likely a totally different type of soil on a flat. So let's go ahead and head that way. This is actually just almost next to the hole that we just dug. And as you can see here, you can see the horizons a little better. You can see this the black matrix, but also you can see these white areas here and some grayish over here. So this looks to me like it's a depleted matrix. I would say more. A depleted dark surface indicator F7. We will look at the depth of it. We will do a. We have this organic material from the first about 7 inches. Then we have this gray on 5 inches. I'm sorry, all this is centimeters. I'm sorry. And then from the first 15 centimeters to below is a little bit, is turning gray. Okay, so here it is in centimeters. You can also put it right here and you see the colors there. This hole is at a depth of almost 50 inches. Alright, now let's go ahead and do a flat surface. But this is actually the what we call a flat surface. If you can actually just look, Jocelyn, can you actually videotape the terrain and just see that it's all flat, because the slope will begin over there. Now in this flat surface here we have the first about 8 inches of what we call coarse granular soil. Centimeters. I'm sorry, centimeters. It's about 10 centimeters, 8 centimeters, 10. And then if you can see students here, look at this, look at like a carpet, look at this. See how I lift this up? And after this is when the other type of soil begins. Now this is kind of like, we call like maybe like a light grayish with some white spots there, up to a depth of approximately 38 centimeters. Now the color and the texture of the soils are very visible. As you can see again, it's like a, see, and then the other part of the soil actually is very, very compacted. All right, see that? This loose material is what we call the first organic part of it. Now let's move on over there, and we're gonna dig another one, and we're gonna see a different type. What we have here is what we call marl. Marl is basically this is a limiting material which is produced by calcium carbonate, produced by algae. Here you have the first 10 centimeters of sandy, grayish black mucky material. And from 10 centimeters and below, you have marl, which is just like sand. Just like, but not quite sand. Very, very, very fine sand, called marl. This is this kind of soil is only found in South Florida. So this is very unique and very common here in this south part of the state. As you can see, here you have a nice way to tell the different types of coloration in the soil. And the texture, of course, this texture here is different, as you can see, than the texture here below. This is called marl. Alright? Alright, and this is actually in a flat surface here in the wetland. If you can actually tell over there, you see that is a slope over there, so we're not on a slope. Okay. All right, so